Welcome. Today we will introduce our project focusing on a significant challenge in our community, enhancing the driving experience for visually impaired individuals with deficiency in color perception. Our solution utilizes the augmented reality and computer vision technology to transform how visually impaired drivers interact with the traffic signal system. We consider the challenge faced by colorblind drivers, such as protanopia, who has difficulty distinguishing green and red. For them, tasks like recognizing traffic lights and navigating busy streets are complex and potentially dangerous. Our project was developed to address this challenge, aiming to making the driving more accessible and safer for this demographic. Our system's functionality begins with the real-time camera images and the depth data from sensors on the AR headset. These inputs are crucial for identifying and locating the navigational elements like traffic lights. The object recognition module processes a camera feed, detecting the pixel coordinates of the traffic light and the face label. The depth information, which is obtained by the simulated depth sensor, is then combined with the output of the CV module. Finally, the AR indicator rendering module uses combined data to render AR indicators in the 3D world coordinates. These indicators are aligned with the detected traffic signals and adjust dynamically to driver's viewpoint, providing a clear and context-aware AR experience. In the showcase, we have designed two types of traffic lights for testing, the traditional layout and the non-traditional layout. For instance, we use a single light as an example, which is quite common practice in many Asian countries. The users will navigate through these scenarios under different conditions to evaluate the system's effectiveness. Initially, the user will experience the simulation in normal color mode, where the traffic lights appear as they would to a person without color vision deficiencies. This serves as a baseline for the comparison. Subsequently, the user will switch to a colorblind mode, simulating the visual experience for a colorblind driver. Here, the system's capability to assist with signal recognition in a visually impaired context will be assessed. In both modes, the user will test the system with and without AR assistance. This comparison aims to highlight the difference our system makes in enhancing the signal recognition and overall driving safety. The AR overlays, tailored for high visibility, dynamically adapt to the traffic lights status and the driver's perspective, providing real-time assistance. From our preliminary test with 11 subjects, we gathered valuable insights. In colorblind mode without AR assistance, all participants struggled to correctly identify the face of the single signal light. However, with AR assistance, they reported a significant improvement in recognizing the signal face. These initial findings, though it's informal, indicates the potential impact of our system in aiding visually impaired drivers. In summary, this project represents a practical application of AR technology focused on driving safety for visually impaired individuals. By integrating AR into a user-friendly system, we aim to contribute to a safer and more accessible driving experience. Thank you. Feel free to contact for any questions.